Hi, Guy Powell here, and welcome to the next episode of the backstory on the Shroud of Turin. If you haven't already done so, please visit guypowell.com and sign up for more episodes. I am the author of the newly released book, The Only Witness. It's a Christian historical fiction tracing a possible history of the Shroud over the last two millennia. Today, we're speaking with Tom McAvoy, and he's a longtime researcher and speaker on the Shroud and other Christian themes. And today, we're going to be talking about Tom's new book called God the Geometer. And the book covers such things as the Big Bang, physics, astronomy, evolution, quantum mechanics, free will, natural evil, and their relationship to supporting faith. There are also two chapters on miracles, one of which discusses the Shroud and includes Giulio Fanti's latest research on the Holy Fire. And I will admit, I'm very, very interested in that. So let me tell you a little bit about Tom. He is a professor emeritus in the Department of Chemical and Biomolecular Engineering at the University of Maryland in College Park, Maryland. He's authored over 200 technical publications, and many of those have been highly cited. He's published 4 papers on the Shroud of Turin, one of which has been read on researchgate.net by over 2,300 people, and that is an enormous accomplishment. So, Tom, let's get started. So,
Okay.
tell us why you started to write the book, The God Geometer.
Well, thank you, Guy. I began working on the material in the book about 20 years ago. And what prompted me to actually start looking at the material was my first wife developed a very rare form of cancer, pseudomyxoma, and it's a horrible cancer. You basically have these mucinous tumors that grow in your peritoneal cavity, and you wind up starving to death because you can't digest food. It's a miserable disease. And so I asked the question back then, while Jesse was still alive, why do these things exist in our world? It's the same question that Job has asked people back in the Old Testament. And people have been, looking at this question for centuries and centuries. So I began to study science and I began to look at scripture, trying to get answers. Jesse passed away. It will be 20 years in 2024, this year, in June. And the insights that I have learned over those 20 years are what I've tried to convey in the book. So the motivation really came from her illness, and I think I have, I know I've learned a tremendous amount over that period of time. So that's why I wrote the book, try to get my insights out to other people.
Yeah, absolutely. And that question of why do bad things happen to good people?
Yeah,
And then, of course, the opposite, why do good things happen to bad people? But
exactly.
is, it is definitely, that is a tough question. And I think that's, for folks that don't quite understand Christianity, they have a hard time with that question, for certain. So, yeah, no, I haven't been able to read it yet. I know you're pretty close to having it out, and I'm definitely looking forward to seeing it and getting my hands into it because I'd love to hear other perspectives on that question.
Okay.
So now the title is kind of interesting. I will admit I don't think I've ever heard of a geometer. So where did the title come from?
Okay. Let me share the screen here, and uh,
It's coming.
okay,
There we go.
and so you can see that.
We can see that, and if you want to play that,
I have.
and then we can do that as well.
Okay, there it is.
Perfect. Absolutely. Wonderful.
You're going to have to lead me through that again, I think. But basically, when I wrote the book, it was on faith and science. And there are a lot of books out there that say, faith and science, or why science and faith are compatible. And I wanted a title that would maybe catch people's attention a little bit more. And I found this image, and I found a description of it on the web. The image comes from a 13th century codex. And the description of the image that's given in Wikipedia is as follows, and I'll read it. Science, and particularly geometry and astronomy, astrology, was linked directly to the divine for most medieval scholars. The compass in this 13th century image is a symbol of God's act of creation. God has created the universe after geometric and harmonic principles. To seek these principles was therefore to seek and to worship God. So this to me was a great image. The fact that I think it was 1320 when it was published in the Codex, and I thought, wow, this is great. I'll use that. And then the subtitle is what I would have used if I didn't find this image: How Science Supports Faith. So that's the basis for the title of the book.
Yeah, interesting. And I love that image. So you said it was from 1320.
Yes.
And what's interesting about that is that image is very similar to a lot of the images of that time of Jesus Christ, which personally, I believe a lot of these stem from having seen the shroud or having seen potentially, images based on the shroud, and then making painting an image of Jesus Christ just like that.
Yeah. So I like the image, and I think the publisher did a good job with the book cover and putting the image on there. So
yeah. So, and who is your target audience for the book?
Well, I think there probably were three. The first one would be people that have really asked Job's question when they either have family members or friends who have developed some of these miserable diseases that are out there, or if they've run into difficulties. Just the question of, why do these things exist in our world? Now, they've been called natural evils, and I don't think that's the correct term for them. I'll talk about that later on. But as I said earlier, that question has been asked for centuries. And so I think anybody that has faced that type of question, that would be one group of people that I wrote the book for. The other group would be, I think, people of faith are almost bombarded today by the media, by university faculty, by celebrities who are either agnostic or atheists. And their message is that, why do you have faith in God? Science has all the answers, and faith is passé, and you really don't need it. And I think nothing could be further from the truth. The more that I look into science, the more that I see the hand of God. So I wrote the book for people that are facing this question and this sort of barrage of negative information about their faith. And then the third group that I wrote it for were my own children and stepchildren and grandchildren and step-grandchildren. But as I mentioned, I've spent roughly 20 years reading a lot of science, delving into the scriptures. And I think I've gotten some interesting insights that I try to convey in the book. So I've written the book so that I could pass those on to those people. So those would be the three groups that I have written the book for.
Yeah, interesting, because I kind of did the same thing for my children, is to give them a story that they can easily read and then yet have it interwoven with different Christian themes and Christian Christian messages. So that makes a lot of sense. And I will admit I was not ready yet, although maybe in my next book I'll try and you can't tackle it, but you can certainly touch on it, and that is why do bad things happen to good people. So kudos to you for doing that.
Thank you.
Now, you, if you don't mind, you mentioned natural evil, which you didn't think was a good term. Tell us about that.
Well, can we postpone that until we get down to
absolutely.
some
Let's
of the
go
other
for
topics, and I'll come back to that. That's sort
Sure.
of towards the end of my book, and for me, I found an answer to the question that I originally posed. So,
Okay. All right. Well, then, yeah, let's get back to it then. And so, what other topics then are covered in the book?
okay, so I think the next slide would go into the topics that I cover. And I put the Big Bang in red because that's the first one that I'll discuss in a little bit of detail. But I've got two chapters on the Big Bang. And to me, that's one of the most amazing accomplishments of modern physics and cosmology. It just it kind of blows my mind when I look at some of the details that have been found. And then people may not be as familiar with our solar system in terms of, and I've got fine tuning there. And by fine tuning, what I mean is just slight changes in some of the aspects of either the solar system or the Big Bang would result in having no life as we know it. And it's amazing the number of things that have to be in place in order for intelligent life to exist. And then there are actually three chapters on evolution, two on evolution itself and one on intelligent design, which I don't think is science. I've got a chapter on quantum physics and free will, on natural evil, so we'll come back to your question there, and then on miracles. And with the Big Bang, you could spend easily an hour talking about the Big Bang or several hours. It's such an amazing subject. So there's no way to do that in 1 hour. But let me pick out one of the things, the energy part, that I talk about in the book. And this is an example. It's not one that people like to look at, but this is Nagasaki after the atom bomb was dropped on it in World War II. And if you look, the town was just destroyed. And the bomb itself contained 14 pounds of plutonium, and less than 1 gram was converted into energy. And in fact, I'll hold up here, hopefully you can see it,
Yep.
is a penny. The amount of plutonium that was converted into energy was 1/3 of the size of a penny. And that energy did this destruction. And you say, how did that happen? Where did that come from? And it all goes back to Einstein's relativity equation, E equals mc squared, that m is the mass of something. So that would be 1/3 of the size of the penny. C is the speed of light. It's an enormous number. It's 186,000 miles a second. So if you square that, that's an even, more enormous number. And a tiny amount of mass will generate just a huge amount of energy. Now, when our universe was formed, and this is what, I don't know, it must be 98, 99% of the physicists believe through the Big Bang. Prior to the Big Bang, there was nothing. Then the Big Bang occurred. So right away, we've got a creation moment, which agrees with what we find in the Old Testament about God creating the universe. And at the moment that the Big Bang occurred, there was no mass present. It was only energy. It was radiation energy. And it was just enormous, an enormous amount of energy. It's the closest thing to infinity that I personally can imagine, the amount of energy that's present. And the best way, or a way to explain this is to, let's see here. There it is to look at taking that equation and just rewriting it. And mass is equal to energy divided by the speed of light squared. So the Big Bang started with energy, but the energy was converted into mass through this second equation. Now, in order to get, say, the mass in my body, I weigh about 200 pounds. The amount of energy that it took was enormous. It'd be enough energy there if you could recover it to, probably wipe out Massachusetts, Rhode Island, all the New England states. I mean, if you look at what the penny did, or the third of the penny did to Nagasaki, fortunately, once stable atoms are formed, you can't get the energy back from them. You can only get the energy from radioactive atoms. But if we then look around, and sometimes when I'm driving, I'll just look out, look at the trees, and look at the road, and look at the houses, and just think, oh my God, the amount of energy that it took to make those is just, it blows my mind. And we're living on one small planet in the universe. So if you now say, well, how much energy did it take to make the sun, to make all the stars, to make all the galaxies that we see out there? It is the closest thing to infinity that I can possibly imagine. It's just enormous. Now, what happened to the energy? The aspects of the Big Bang that are absolutely amazing are involve the time scales and just how mass was created from the energy. Nuclear fusion took place right after the Big Bang, or not right after, but shortly after. And hydrogen and helium were produced. Now, nuclear fusion is what occurs in our sun, and that's what generates energy for us from the sun. The nuclear fusion only lasted 20 minutes because the universe was expanding at such a rate that the collisions between the nuclei didn't happen after about 20 minutes, such that the fusion could go on. So after 20 minutes, the only nuclei of atoms that were present were helium, hydrogen, and a tiny amount of lithium. There was no calcium, there was no carbon, there was no oxygen, there was no nitrogen. Everything stopped. And then for 100 million years, no more fusion took place. It's like, oh my God. Now, the Big Bang occurred roughly 13.8 billion years ago. But for 100 million years, there's no more fusion. And then stars formed, and all of a sudden, fusion started to take over again. And how we got the atoms in our body, to me, is equally amazing, that these were created in stars that died. That once hydrogen is used up in a star, the helium starts to fuse, and it will fuse into heavier elements. It'll fuse into carbon, it'll fuse into nitrogen, oxygen, and whatnot. And all the heavier elements were made in stars that died. And when they died, then the material in them was available for other stars and planets to be used. So we can think of ourselves as being either, if you're an optimist, we're made of stardust. But if you're a pessimist, we're made of nuclear waste that occurred in a star that died. Now, I have in the list of topics, I said, or I made a point of putting fine tuning. If the parameters of the universe, if the physical constants were not superbly fine-tuned, we wouldn't be here. There are two possibilities that would easily occur. One would be after 20 minutes, we had all helium. The other would be after 20 minutes, we had all hydrogen. And it wouldn't take much of a change in the physical constants, a very tiny change, for that to happen. And that's just one example. There are at least 10 or 12 examples of constants that need to be superbly tuned in order for intelligent life to exist. And physicists and physicists that are, atheists and agnostic recognize this. And so their answer was, well, we must be part of a multiverse, that we're just one universe in an almost infinite number of universes, and we're in the lucky one. But I think a much better rationale or description is that God fine-tuned these parameters so that intelligent life would exist. So I talk about the Big Bang and the fine-tuning in one of the chapters.
Well, and I think to your point, that fine tuning of those parameters, and there's only a handful of them that really describe, just about everything in the universe. And getting those exactly right, I think you're right. Either the multiverse is maybe right, or it was designed by God to finely tune them so that absolutely, the hydrogen would be made and go into the stars, and then all of that would then progress until we have galaxies, solar systems, Earths, and then the humans.
Yeah, and our star, our sun, is a third generation star. It's been around for about 5 billion years, and it has elements in it that came from other dead stars.
Mm.
And the same with our planet. I mean, all of the material that we see around us came from stars. So it's pretty amazing. Now, I think, let me just see if I can move this up one. The next topic I will mention is our solar system, which I said most people probably don't appreciate the fine tuning. And I've got in there probably 7 or 8 different interesting aspects of our solar system that if they weren't the way they are, there'd be no intelligent life. I think a lot of people look out at the universe and they realize that there are, billions of galaxies out there, and, all sorts of planets, and, there must be intelligent life elsewhere. There may be, but if you look at what we have in our solar system and what it takes for us to exist, I'm convinced that there won't be a very large number of planets in the universe that would sustain intelligent life. There may well be some, but it's not nearly as common as people may think. Now, I've got one example that I can give, and I think it's on the next slide, and it's our Earth. And so here's a schematic of our Earth, and it rotates. It rotates a little over 23 degrees from the vertical, and it spins around, and it also goes around the sun. And the rotation is important in terms of, it is involved with the seasons and whatnot. But the reason that this angle is maintained is due to our moon. Now, most people don't realize or think about what would happen if we didn't have the moon that we have. Our moon is roughly 25% of the size of the Earth. It's a relatively large moon compared to our planet. And the moon stabilizes this axis of rotation. So it doesn't change. And the moon has a pretty significant gravitational effect on the Earth. We know that because of the tides. But here's what would happen if we didn't have a moon that was that big and that could actually do that job. Over time, the axis of rotation of the planet would start to wander. So here I show it, going from 23 to maybe 45 degrees to 90 degrees. And if you look at, for example, up here was the North Pole, all of a sudden the North Pole is down at the equator. And the equator is up at the North Pole. So what we're going to have is a situation where it's impossible for complex life really to evolve because the environment is changing where the life exists. And so if this were true, there would only be small regions on our planet where complex life would exist without a moon. People can actually Google what would life be like on the planet without a moon. Now, Mars has 2 small moons, and they're not big enough to stabilize its axis of rotation. So Mars actually exhibits this kind of behavior over time. And that's one of the problems with potentially with life on Mars. Another thing that our planet has, and as I say, I list 7 or 8 of these in the chapter. I'll just mention the moon here. But another one that's interesting is we have a magnetic field that's produced around the Earth. And the reason we have that is that we have a molten iron core, and it's kept molten due to nuclear reactions in the interior of the Earth. And this is what causes volcanoes and earthquakes and things like that. But the liquid iron provides a magnetic shield around our planet. And the advantage of that is that cosmic rays that are coming in from the sun get deflected and they never hit the planet. If we didn't have the magnetic shield, then our atmosphere would be stripped away over time. And that's exactly what happened to Mars. Mars lost its atmosphere because it doesn't have a magnetic core. It doesn't have a molten core. So looking at, all of these potential planets around the universe that are going to exist, if they don't have a molten core, they're going to have trouble with cosmic rays stripping off any atmosphere that they might have. If they don't have a moon that can stabilize their axis of rotation, then they could be experiencing changes in climate over time that are going to be detrimental to life. The other thing that we have, or one other thing that we have, is we have a neighbor, Jupiter, that's an enormous planet. I forget I was going to look it up and I forgot to, but it may be 300 times larger than the Earth, but it's huge. And it acts as a baseball catcher. It catches asteroids. So as the asteroids come in, Jupiter, through its gravity, winds up capturing them and they don't hit the Earth. Now, one did hit the Earth 65 million years ago. And when it did, it wiped out the dinosaurs and about 70% of life on Earth. And there was one estimate that I saw where if Jupiter didn't exist and be our neighbor, then we would probably be hit maybe 10,000 times by asteroids. And if one of them took out 70% of life, you can imagine what 10,000 would do. There'd be no opportunity for life. So if you look at all of these facts about our solar system, to me, it's absolutely amazing that, someone wasn't behind the design of our solar system as well as our universe. And as I say, most people may appreciate the universe, but just some of the facts about our solar system are absolutely amazing.
Yeah,
so that's another topic in the book, and I go into detail on the fine tuning.
Yeah, there are so many things like that. I also like reading about, space and space science, and I don't know what you call it, but all of the little things that have to happen to have the Earth be a stable environment and stable over, millions, hundreds of millions of years for life to be able to evolve from something that's relatively uncomplex, single cell, to being where it is today with, the complexity not only of us, but of all of the animals and everything like that. Yeah, absolutely. And then I like your point about Jupiter. Jupiter absolutely does protect us from the asteroids and things like that. So absolutely. Thank you.
And fortunately, even though it's a neighbor, it's far enough away that it doesn't suck us in and screw up our world. So just where we are in terms of our relationship to the sun and to the neighbors is another fine-tuning aspect of our solar system. Now I have some other topics. I'm not going to go into detail on them because we don't have we're limited with time.
Well, we'll get you on the next round then.
I do talk about evolution, and this is probably the topic that causes the most heartburn with believers. And so I've got chapters on evolution, and two of them address questions that basically leading atheists, I guess, have proposed. One is Stephen Gould, who wrote that if evolution could be rerun, it would not lead to intelligent life. And so I've got a chapter that uses other scientists and what they've done, and plus some of the material that I've done as an engineer that involves genetic algorithms to point out that he's wrong, in my opinion, and in the opinion of the other scientists, that if it could be rerun, it would lead to intelligent life. And then the second chapter is one that addresses what Daniel Dennett proposed, that evolution is purposeless. He said it's a purposeless algorithmic operation. And again, I discuss the purpose of evolution and the fact that Dennett is just wrong on his assertion. And then there is a chapter that I talk about on intelligent design, which is aimed at really denying evolution, I think. And it's not scientific. And I think evolution teaches us a lot about faith and God's intention. So there are a couple of chapters on evolution. Now, the chapter on free will and quantum physics may be in some sense, the deepest chapter. One of the things about quantum physics that I find fascinating is if you compare, for example, I'm sitting here and I'm sitting at a table, and I know the table is stationary, it's not moving, and I know its position, it's right in front of me. If we look at the microscopic world that involves atoms and molecules and whatnot and their components, you cannot say at the same time you know the position and the velocity of a molecule, of an atom. It's theoretically impossible. It's Heisenberg's uncertainty principle. So the quantum world, the microscopic world, is not deterministic. The macroscopic world is. So by deterministic, I mean that you know the position and the velocity of what you're looking at. And it has some really unbelievable aspects to it. But what I talk about is what would happen if the microscopic world behaved like the macroscopic world. Suppose you could know exactly where a particle was and its location. So everything was deterministic at the microscopic world. Then basically there'd be no opportunity to change anything. Everything would just go forward without any chance of any change at all. So in order for us to use our free will to make changes, we really need this quantum world with its probabilistic nature. You can only say the probability of the location is this, the probability of the velocity is this, and you can't specify the exact values. So it's kind of an interesting philosophical point, but we have a world we live in that allows us to use free will, and yet on the macroscopic scale, it is deterministic. So we can, basically send people to the moon and things like that. But
although technically, the fact that it's probabilistic, and if that was designed by God, then that was intelligent design of that piece, just at a totally different scale.
Exactly.
Yeah, very interesting.
And then natural evil. I personally think that natural evil is the evil shouldn't be associated with it. I think that in order to use our free will, we need to have some things to be free about. If I look back and think, if we lived in the Garden of Eden and everything was taken care of for us, and there were no issues that we had to deal with, the question I raise is, would we be happy with that? I don't think we'd have anything to use our free will about. I mean, so I think the fact that we're free and the fact that we run into some of these miserable diseases and miserable issues in life, I think those two things go together. So I don't think it's evil so much as natural evil. I would say is just nature, and it's just due to the fact that we have free will. So, and then the last thing I'll spend a little time on are miracles. And let me, we're in, let's see. our picture is blocking out. I made the font too big, but this says miracle equals data in quotes for faith. And this is kind of my idea of a miracle. Now, what do I mean by this? And why is data in quotes? If I have an experiment that I want to run, either as a scientist or an engineer, I will run replicate cases. I'll run an experiment, usually run another one, and gather a lot of data, trying to duplicate the same conditions. A miracle, as far as I know, I don't think there are any duplicate miracles. I think miracles are typically one-off events that happen. And you're not repeating them per se. But the thing that happens is that, the miracles that I talk about in the book are what I call essentially modern miracles, where there is a physical basis for them that can be examined. For example, both of us are interested in the Shroud of Turin. Well, the Shroud of Turin exists, and there've been an enormous number of scientific studies on the Shroud of Turin. Another miracle I talk about is one that happened at Lourdes, Jack Traynor or John Traynor. And it happened just about a little over 100 years ago, where he was cured. And there are medical records for his cure, and there are photographs of him leaving on a wheelchair to go to Lourdes and coming back pushing the wheelchair. I talk about modern Eucharistic miracles where hosts have been changed and people have examined the hosts and studied them scientifically. Fatima was another miracle where there are newspaper reports and photographs. And there's also Our Lady of Guadalupe, the tilma that Juan Diego had the image of Mary imposed on. Now that happened, I believe, in the 1600s, but the tilma is still available in Mexico City, and it has been studied, not nearly as much as the shroud. So I think the fact that you can get physical data for miracles is important. And it's not data where you're going to look at 2 or 3 or 4 shrouds. You've got one shroud, but you can actually get physical data from the shroud. Now, many scientists just rule out of hand the fact that a miracle can occur. They just say, no, it's impossible. And I think the proper way, or the proper approach they should take to a miracle, is to say, okay, we'll look at the facts, and either you're going to say the facts, here are the facts, and they speak for themselves, and one, we can't explain them with what we know about modern science, or 2, a miracle occurred. But just to rule them out of hand
right.
Is the wrong thing to do. It just isn't scientific in my opinion. Now, what I do in the book is, I don't try to, in Traynor's case, I have a whole chapter discussing his cure. And, but for the other miracles that I talk about, I give more of an overview of them, like for the shroud, for the image of Our Lady of Guadalupe, for the Eucharistic miracles, and for Fatima, and then references that people can go on their own and look up material on the web. So it's not meant to be, books and books have been written on the shroud itself, so it's not meant to be exhaustive. But let me talk a little bit about the shroud, and I highlight in that chapter what a lot of what Professor Giulio Fonte has done. And his work, to me, is absolutely fabulous. He's very widely and highly published. The work that he's done on dating the shroud with alternative dating methods to the radiocarbon dating has been really, really magnificent. But his recent work on the divine photography hypothesis, to me, is fascinating. Now, I've got a picture here. I think it comes up next. This is a picture that Giulio let me put in my book, and it's taken from his recent book on the Holy Fire and the Shroud. And he also published a paper that is available that shows this photo. And what you see there is Giulio is holding a bunch of candles that are lit. He's holding it under his chin, and he's not being burned. And the holy fire is a phenomenon that has occurred basically every year since the 4th century in the Church of the Holy Sepulchre in Jerusalem. And recently, there have been measurements made that when the fire occurs, they measure electromagnetic changes around the tomb, around Christ's tomb, where the fire occurs and causes a candle to be lit. And then the patriarch comes out with the candle and he spreads the flame around to everybody else in the church. The interesting thing about the flame is that for about 10 or 15 minutes, it's a cold plasma. Now, what's that? Well, it's a flame, but it's cold enough that it doesn't burn. Now, after 15 or so minutes, it warms up. And if Giulio had tried this, let's say after a half hour, he would have gotten burned. But when it first comes out, for 10, 15 minutes or so, it basically, it's a cold plasma. Now, you can create cold plasma in laboratories, but how it could be created in a church is nobody can explain. And in fact, they conclude, Giulio and his co-author conclude that just the cold plasma aspect of this is miraculous, that there's no way to explain it. And Giulio has in the book and in his paper, he lists 24 different aspects of the shroud that he would like to explain. You know, how did the image get there, and various questions that have been raised. And he believes that this holy fire potentially can explain all 24 aspects of the shroud's image. It's really fascinating research. And the shroud itself, the best explanation of the image is that it was caused by radiation. And if that's the case, the radiation would have occurred at the time of the resurrection. And that in itself would be a miracle. So, so I have, as I say, I've got a description in there of the shroud, of Giulio's dating research, and then a discussion of his latest research on the holy fire and its connection to the Shroud of Turin. So,
yeah, one thing that I find fascinating, and quite a few people, I think, also misinterpret this, or maybe haven't thought about it. But one of the challenges is that the Earth spins around the sun, and it takes 365 and a quarter days. And then every 4 years we have a leap year and what have you, and that changes the calendar. And this holy fire, though, is at the same time of the day, at the same day of the year.
yeah,
You have to realize that the day is actually changing by 25% every year.
yeah, yes.
So therefore, what's interesting is that, you know, and when we talk about, you know, 365 and a quarter days, that means that we're in exactly the same position, you know, plus or minus, you know, whatever it is, a couple of seconds in the circulating the sun.
Yeah.
But the holy fire is generated at a different time every year. It's off by, you know, it's off by 6 hours a day, 6 hours, which means that when the patriarch goes into the Holy Sepulchre and starts to pray, he is, through his prayers, able to start that fire. It's at least my conclusion. Because otherwise, it's not like it's the same time every year. It's a different time every year. It's off by 6 hours every year. And not to mention the fact that you have the Gregorian and the Julian calendar, which also throws some things off a little bit. So this is, to me, one of the proofs of the ultimate power of prayer, that he can, through his prayers, start something like that.
Yeah. Yeah, and in the West, we haven't heard about this as much because it's the Orthodox Holy Saturday, and I forget
Mm.
which of the two calendars the Orthodox is based on, whether it's Gregorian or Julian,
Yeah, yeah.
and they don't coincide necessarily. So that
Well, but that's where my point is, though, is that the Gregorian and Julian are off by about 10 days,
yeah,
and I think they're only off by a week, so they've then lost 3 days, which
yeah,
means it's not based on the same position around the sun every year.
yeah,
And then, like I said, it's also off by that quarter of a day.
yeah,
And so therefore, it can't be that it's an anniversary or anything like that that takes place. It has to be something else that does it, which is then the only thing is then, in my mind anyway, is the power of prayer.
yeah. Well, it's a pretty amazing phenomenon, and I'm
It
glad
is.
Julio has written this up and started to publicize it. So in the West, we can learn more about it because I think
Mm.
a lot of people in the West just don't know about it, but they do in the Orthodox community. So I've got I've got this in the book as well, along with the other miracles, and I believe
Yeah,
this is my last. Let me say, stop sharing. This is my last PowerPoint slide.
fantastic. Yeah,
So
so we've got only a couple of minutes,
yeah.
and fascinating so far, and I am definitely excited about getting a copy of it. And I mean, it really touches on a lot of things that you're trying to put in line. How does science and God and faith all work together? And it sounds like you're offering some very, very, very interesting thoughts as to how to reconcile the two. So, what do you hope people will come away with when they read the
Well,
book?
I think I guess two things. One is that rather than being intimidated by the fact that science has all the answers and faith is passé, I hope people would come away realizing the fact that the more one looks at modern science, the more you see the hand of God. That if anything, science and faith are really dealing with two different domains. And one of the reasons that scientists say, "Oh, miracles can't exist," is, well, if you just stick to the physical domain, that they can maybe make that claim. Uh, but I think that if anything, modern science supports faith. And I read a book recently. There was a great book called "Seeing is Believing" by Michael Gillen, and he's a guy that has 3 different degrees from Cornell in physics, astronomy, and mathematics.
Mm.
But he points out some of the interesting aspects of quantum mechanics, the fact that light can be both a particle and a wave, and things like that. And so, and his point was that when he saw the New Testament, he saw a lot of this. He calls it translogical thinking in there, that Christ could be God and man at the same time. And so I think, if anything, modern science supports faith. And the other thing is that the more I look at it, and it's a hard conclusion to come to, but I don't think that natural evil is evil per se. I think it's just nature, and I think that
Mm.
we have a challenge to deal with nature and use our intellect and our free will. And so those would be, I guess, the two major points that I would hope
Yeah,
people
yeah,
would come up with.
fantastic. Well, I'm definitely excited about reading it and getting my hands on it. So it sounds like you're just a couple of weeks away. So
Should
where can they find out more about the book and potentially, hopefully, lead them in a handful of weeks to purchasing it?
well, it should come out on Amazon. The publisher is Whiff and Stock, and they have a website. Or if they wanted to email me, McAvoy@umd.edu, I'd be happy to point them in the right direction. I am turning in the final typeset proofs today, and I think it'll take 4 to 6 weeks before it comes out. So I'm excited to see it come out in print. So
Yeah,
thank you
fantastic.
very
Well,
much for having me on the podcast. I appreciate it, and your comments.
oh, absolutely. No, thank you for being on the podcast, and thank you for something that's so enlightening. I was an engineer as an undergraduate, and all of this stuff you're talking about is like music to my ears, because I always have trouble how to reconcile the science that we learned with then the faith that we have. And it sounds like you've made some enormous progress there to help to explain that. So I'm very excited and very interested in learning more about that and reading your book.
Well, thank you very much.
Yeah, thank you, Tom. And so for the rest of the audience, and say again where people will be able to find it. It'll be on Amazon.com.
Amazon.com, and then it's WIF, WIPF, and stock, STOCK.com is the publisher. And hopefully it'll be out in other bookstores. I'm going to approach a whole bunch of them and let them know that it's in the
Sure.
works and get it out.
Yeah. And the book is going to be called The God Geometer, The God Geometer.
God the Geometer.
God the Geometer. Okay, thank you for the correction. Yep. And then the author, Tom McAvoy, and God the Geometer, and available hopefully in a couple of weeks. And by the time this podcast comes out, it'll be very, very close to when it's available. So, Tom, thank you so much. And for the audience, please stay tuned for many other videos in this series of the backstory on the Shroud of Turin. And if you'd like to, please visit guypowell.com and sign up for more episodes. And if you like this one, and I especially like this one because it is very near and dear to my heart, and really then helps to that struggle between how to reconcile science and faith. So I will rate this 5 stars, and please, if you do as well, that would be fantastic. Tom, thank you so much.
Thank you very much. Thanks for inviting me.
Absolutely.
Take care.